Welcome to SLTC. Located in Trace City, Colombo for postgraduate students. And Paducah for all other undergraduate programs. SLTC, where dreams become reality. Nestled on a serene 35-acre campus, our university offers a peaceful haven for over 2,500 students to thrive academically and grow as complete, all-round individuals in all aspects of life as responsible citizens. Our campus is not just a place to study, but a place to live. We have a tight-knit student community with a hostel capacity that boasts 800 dorm rooms. Spread out across the campus are 2 canteens which are open all through the day, all coming together to provide students a vibrant, supportive community. We groom our graduates to make a positive impact on society, and we're proud to be ranked 2nd among non-state universities in Sri Lanka and 14th overall. With a remarkable 15-to-1 student-to-lecturer ratio, personalized attention is at the core of our teaching philosophy. Our majority PhD-qualified lecturers bring real-world experience into the classroom, ensuring students learn not just from books, but from the wisdom of professionals. At SLTC, our commitment to excellence is evident across all our faculties. The Faculty of Business Management equips future leaders with the skills to excel in the global market. Our Faculty of Engineering fosters innovation and practical problem-solving skills, preparing students to tackle the challenges of tomorrow. The Faculty of Science lays down robust foundations, honing the curiosity and the thirst for answers in their journey across scientific inquiry and discovery. The Faculty of Computing and IT empowers students to become pioneers in these rapidly evolving fields. At SLTC, our dedicated Faculty of Technology is at the heart of our modern world. University life at SLTC isn't just about textbooks and lecturers either. We offer a vibrant calendar of events, from exhilarating concerts, theater, gatherings, and engaging clubs, to competitive sports activities. We have a long list of talented students who have even achieved national recognition in multiple sports disciplines. We understand that navigating university life can be challenging. That's why our dedicated non-academic teams and supportive staff are available to assist you every step of the way. From academic advisors to career counselors, we are here to ensure your success. You want to achieve it. At SLTC, we also open doors for our students into the international market with transfer options to prestigious foreign universities, ensuring they have every opportunity to pursue their academic journey on a global scale. SLTC, join us and forge your path to a brighter future. Your journey begins here.
Good evening, everyone joining us today. We truly appreciate your commitment, especially given the current situation in Sri Lanka and the unpredictable weather conditions affecting many areas. Your presence means a great deal for us. We also understand that the several participants were unable to join today due to these current challenges. Please note that the full recordings of today's session will be also shared with you all, so no one will be missing out the learnings we have planned. Despite a few technical difficulties along the way, we made it to a priority to keep our promises and ensure this webinar takes place as scheduled. Thank you for your patience and understanding throughout. Before we begin, I want to extend our sincere wishes for everyone's safety and well-being. Also, a special thank you also goes to Dr. Lasith, who has joined us today. So Dr. Lasith is our senior lecturer, Electronics and Telecommunication Engineering, Faculty of Engineering, SLTC. So that we are very grateful to have his expertise leading today's session. With that, it's now my pleasure to hand over to Dr. Lasith. Thank you very much.
Hello, am I audible?
Yes, doctor, you're audible.
Right. Good evening to all of you, and thank you very much for that kind introduction. I'm Dr. Lasith Yasakethu from Sri Lanka Technology Campus, and I'm attached to the Faculty of Engineering. So today, in this webinar, I'm going to discuss about intrusion detection. Right. So let's see what are the content that I'm going to cover today. So first and foremost, we'll understand what we mean by intrusions. Then, what is an intrusion detection system? Then, how can we perform intrusion detection via machine learning? Then, what are the different intrusion detection approaches available? And then we will look at what type of input data that we can use for intrusion detection. Afterwards, we'll look at some of the widely used machine learning techniques in intrusion detection system. And finally, we will look at the future of intrusion detection. Okay, so I understand that most of the audience here are like students who have completed A-level. So I'm not going to go into the depth about intrusion detection systems because it requires, little bit of like mathematics and things like that. So I'm going to cover the fundamentals related to intrusion detection system during the webinar. Okay. So what are intrusions? Intrusions are actions that attempt to bypass security mechanisms of any computer system. So if anyone tries to bypass the security mechanism of a computer system, that can be defined as an intrusion. There are two types of intrusions mainly: outside intrusions and inside intrusions. Outside intrusions means attackers trying to hack into the system via the internet. right? So inside intrusions means employees. If you take a company, the employees of the company may try to access unauthorized privileges. So that is also an intrusion. So a typical intrusion scenario is, you can see a typical intrusion scenario, a diagram of a typical intrusion scenario here. So what basically happens is that the attacker keeps on searching for a vulnerable point in the computer network. Okay? Keep on searching for a vulnerable point in the computer network. So when the attacker ultimately finds a vulnerable point, it will compromise the system through that point. So that is what basically happens in an intrusion scenario. And now let's say, what are the different type of attackers we have who try to, hack into systems? We have four main, we can categorize them into four main categories. The first one is internal and non-malicious. That means employees or could be contractors causing unintentional damage, right? So they are internal people. They may cause unintentional damage. So therefore, the risk level is very low. Then there could be internal malicious attacks. That means there could be employees with very good knowledge of the system, and they might try to intentionally cause damage. So that is also a possibility. And the risk level here is high because they are doing it intentionally. Right. Then there could be external opportunistic. That means hackers seeking a challenge. There are people who just like for fun, they want to hack. Right? So the risk level there is between low and high because, depending on what sort of system that they want to hack, the risk level differs. And the most dangerous type of attackers are the external deliberate category. They are malicious, they are organized crime groups, and they could be well funded by political groups. Right? So the risk is extremely high. So what are the main targets of these organized crime groups or organized attackers? They mainly target critical infrastructure. So what do we mean by critical infrastructure? For example, electrical grids, telecommunication networks, nuclear power plants. So these are some examples for critical infrastructure. Now, this critical infrastructure rely on diverse interconnected information and communication technologies. And the issue is these technologies are vulnerable. That is why attackers try to exploit these vulnerabilities. So finally, this may lead to very dangerous situations, exposing the system to attacks. And there's a very famous incident, I don't know whether you have heard of it. It's called the Stuxnet incident, which happened in 2010, June 2010 in Iran, where a group of well-organized crime group tried to attack the critical infrastructure. Now, I'm going to talk about this towards the end of my webinar. Right. So, now it is very clear, right? To prevent intrusion, we need intrusion detection systems. And they are necessary to protect critical infrastructure. So that we know. Now, intrusion detection is basically a process of monitoring the events in a computer system and analyze for possible threats. So we keep on monitoring the events in a computer system and we check whether there are threats. So that is a simple idea. And here you can see a conventional cybersecurity system with intrusion detection. So on the left-hand side, you see cybersecurity threats like viruses, Trojan, worm, spam, etc. So these are the cybersecurity threats, and we can have a intrusion detection system at both network level as well as the host level. So the network defense system might include a firewall, a spam filter, and antivirus. And the host layer, we might have things like firewall and antivirus. So this is an IDS or an intrusion detection system. Okay, now back in the day, the intrusion detection was performed by human beings, right? They were analyzing the data and they were doing the intrusion detection. So the problem with that is it is extremely difficult. There's a lot of data. And if a human being tries to go through all this data, it is extremely difficult and it will take a lot of time. So it is basically like mining a needle in a burning haystack, right? There's so much hay and there's so little time. I mean, like finding a needle in a haystack itself is very difficult. And imagine while it is burning, you have to find it very quickly. So that's a very good example to compare with manual intrusion detection. So what is the solution? So we understand that manual intrusion detection is difficult, time consuming. So as a solution, we propose machine learning, which is a branch of artificial intelligence for intrusion detection. So how does machine learning help us? So it helps to develop automated systems that can learn from data and act accordingly. So machine learning systems are capable of developing an automated system which will learn from data and will say whether the events are either normal or as attacks. So this machine learning techniques has the capability to gather knowledge from the data, as I mentioned, and then they make predictions about the new data based on the knowledge they acquire. So they use data and they acquire knowledge. And when the new data comes in, they predict whether it's an intrusion or not. So that is the basic idea. Right. So malicious users attack the system vulnerabilities by using a sequence of events. So these events result in characteristics that are defined by patterns of attack. Right. So these machine learning techniques, they basically analyze these events to detect the patterns and determine whether they are possible threats or not. So here you sort of see a flowchart which will show you how the detection is done. Now in stage 1, what we do is the events are analyzed and patterns are detected. Okay, so you basically analyze the events and you derive patterns. So if the patterns are known, then the relationship between the data elements are identified. So once you know the relationships, then the context of the data elements is identified. If you know the context, then the meaning of the data is understood. The meaning means either it's normal or abnormal. Abnormal means it's suspicious. So here, what do we mean by context? Context means why certain data values appear and what situations they belong to. So let me try to explain that to you through an example. So let's say there's an employee trying to log in to the system at 3 a.m. in the morning. So that could be normal if this employee is working during night shifts. So, I mean, if he or she is working during night shifts, a login attempt at 3 a.m. is quite all right. But it would be suspicious if the employee usually works during office hours. Then it's a suspicious login. So that is what we mean by context. Right. So apart from intrusion detection, what are the other areas we can apply machine learning for security purposes? For example, fraud detection. By fraud detection, we mean like detection of criminal activities in commercial organizations, such as credit card fraud, insurance claim fraud, and mobile phone fraud, and also insider trading. Another area would be industrial damage detection. That is basically detection of different faults or failures in complex industrial systems. For example, in aircraft operation, we may try to use machine learning techniques to identify anomalies in engine combustion data. Another area is video surveillance, to detect outliers in images monitored over time. So we can use machine learning to for videos or a set of images that is again a video. So you can analyze the video and figure out what are the outliers. Okay. Now, when we take a machine learning based intrusion detection system, very simply, this is what happens. So the monitoring data comes in, then the machine learning based IDS will analyze the monitoring data and it will say whether it's a normal event or an attack. So that is the simplest way of explaining it. Now, we have three types of machine learning techniques: supervised machine learning, unsupervised machine learning, and semi-supervised machine learning. In supervised machine learning, we have two stages: training and testing. So what do you mean by training? Training means you use data to train the system. So what type of data do you use? You use both attack as well as normal data to train the system. So once you train the system has an understanding, knowledge about attacks and normal behavior. Then during the testing stage, when the new data comes in, the system is capable of detecting whether it's an attack or normal. So this basically requires prior information. That means normal data or attack data for training. And in intrusion detection, this we call it like require label information. So that means the training data that we use needs to be labeled as attacks or normal. Right. Then unsupervised machine learning, it has only one stage, that is just the testing stage. So you do not need any prior information or knowledge. So there's no training. When the new data comes in, you just simply say whether it's a normal or an attack. Then finally, semi-supervised machine learning. Semi-supervised machine learning is an intermediate stage between supervised and unsupervised machine learning. Here we use some prior information or knowledge for semi-supervised machine learning. Okay. Now, let's see what are the different intrusion detection approaches available. There are mainly two intrusion detection approaches available. The first one is signature detection, or we call it misuse detection. Here what happens is alarms are generated when a known attack occurs. So it is very important to understand here, the alarms are generated only for known attacks. Okay, only for known attacks. Now, how does it happen? Now, here you can see that there's a database of attack signatures, right? So there's a database of attack signatures. So patterns derived from system behavior would be compared with the database of attack signature. So if there's a similarity match, that means it's suspicious, right? Because you are comparing it with a database of attack signatures. So if the patterns matches one of the signatures, that means it is a suspicious behavior. If it does not match, the system would say it's not an attack. So this will keep on rolling to detect patterns one after the other. Right. So what is the advantage of this system? It has a low false alarm rate. So what do you mean by false alarm? Alarm means you flag it as an attack. So what do you mean by false alarm? That means you flag it as an attack, but actually it is not an attack. Okay? So you say it is an attack, but actually it is not an attack. So the advantage is it has a low false alarm rate. So why is the alarm rate, the false alarm rate is low? Because here each pattern is compared with a database of attack signatures. So there's a very less likelihood that you flag the event as an attack if it is not actually an attack. But the disadvantage of this system is that only known attacks can be identified. Because the thing is, the patterns are compared with database of existing attack signatures. So if a new attack comes in, although you match it, there's no similarity match. So you will say it is an normal behavior, but that's a new attack. So actually it is not normal, it is an attack. So therefore you can only known attacks can be identified. If a new attack comes in, it cannot be identified. Right. So the second type of approach is anomaly detection. Now, anomaly detection generates alarms when events behave different from the normal behavior of the system. Right. So what is the normal behavior of the system? Now, for example, let's take a electrical grid type of a critical infrastructure. So we know the normal behavior of our electrical grid, let's say, right? So we know the normal events, we know the normal data, therefore we are well aware about the normal behavior. So as you can see in this XY diagram, you have N1 and N2 with lot of data. So that is corresponding to the normal behavior. Then anything outside the normal region is considered as an anomaly. So here you see A1, A2, A3. Now these are anomalies, right? Okay. But the problem is, so if an attack comes in, okay, if there's an attack, definitely it is not belonging to the normal behavior. So it is going to be and out it is going to be a point outside the normal behavior like A1 or A2. But there could be an instant, for example, let's say if we want to carry out some sort of a maintenance in the system, due to the maintenance, the data created might not fall in the normal areas. So it might again fall outside. Then it would also be identified as an anomaly. But actually, it is not an anomaly. It is due to some sort of maintenance that the employees carried out. So what is the advantage of this approach? The advantage is unknown attacks or novel attacks can be identified, because any novel attack would fall outside the normal behavior. The disadvantage is there's a high false alarm rate. So now you know what is false alarm, but it is high because, you know, things like maintenance, I said, right? So you flag it as an attack, but it is not actually an attack. So it's a false alarm, and many of such could happen if we are using anomaly detection. Okay, now let's see what type of input data that we consider for intrusion detection. Now, the most common form of data handled by intrusion detection is monitored data or recorded data. Now, there are two types of monitored data. Univariate, that means they consist of a single variable and very rarely used in complex cybersecurity scenarios. So it's just a single variable. So the knowledge that we can gain from that is limited. Then the next type is multivariate. That means it uses several variables and is the usual type of data needed for strong detection. Now, here you see a set of input data that we use for intrusion detection, which is of multivariate type. Now, if you look closely, you will see that there's a source IP, there's a start time, there's a destination IP, there's a destination port, there's a number of bytes, and here whether it is an attack or not. So you see that no means no attack, yes means it's an attack. So this is like training data. This is training data multivariate training data that we use for supervised learning. So now this yes and no are the labels that I mentioned earlier, right? I hope you remember I said that, you need label information for supervised learning, right? So now let's look at the nature of multivariate data attributes. So multivariate data attributes could contain binary data. That means only two possible values, either yes or no, true or false, or 0 or 1. So it's binary. Or it could contain categorical. Categorical means group of labels. So as you can see here, the source IP or the destination IP is categorical type. So because see, there's group of labels. So that is categorical. So the third type is continuous. That means the numerical value can take any value within a certain range. So for example, if you look at this duration attribute, so that's continuous. It will take a particular value within a specified range. Or you can have combination of several attributes. That is also possible. So most of the machine learning techniques available today are capable of handling complex multivariate data. Right. So let's look at an actual example, right? Now, let's look at data used for network intrusion detection. Okay. Now, for network intrusion detection, we rely on TCP/IP level information. TCP means Transmission Control Protocol, and IP means Internet Protocol. So TCP/IP level information means the basic details inside packet that computers use to send across a network. So you know that when computers try to communicate with each other in a network, they take the information and divide it into packets. Then they use routing to send the packets to the destination. So that is what basically happens. Now when we take this TCP/IP data, there are a lot of features, as you can see. Source IP, destination IP, protocol type, packet size, time interval, etc. So this is an example for multivariate data type. Okay. So what are the widely used machine learning techniques in intrusion detection systems? Here I have listed some, but it is not limited to only the techniques that I have listed here. These are the more popular ones, I would say. So support vector machine, or we call it SVM. Decision trees and random forests is another technique. K nearest neighbors, KNN. Artificial neural networks, ANN. Naive Bayes, OK means clustering. So these are some of the widely used machine learning techniques. Now, here I have listed the advantages and disadvantages of each of these techniques. And I'm not going to go through the advantages of disadvantages, but I want to show you that each of these techniques has their own advantages and disadvantages, right? So if you look at the next three examples also, the same, they also have their own advantages and disadvantages. So when we have many machine learning techniques with advantages and disadvantages, how do you pick the right one? So how do you select the right detection strategy? Okay, so there are some important factors that we consider to decide what is the right machine learning technique. The first one is whether labeled data exists. So if you are relying on a supervised machine learning technique, you need labeled data, right? Because you need to train the system, so you need labeled data. And if the labeled data is unavailable, then you have to go with an unsupervised based machine learning technique. The next point is, do you want to detect only known attacks, or do you want to identify unknown attacks as well? So if you want to detect known attacks, you have to go with a signature-based approach. If you want to identify known attacks, you have to go with an anomaly-based machine learning technique. Another important factor is the expected level of accuracy. So what sort of accuracy would you expect from your IDS, intrusion detection system? So for example, if you want to have an IDS with more than 80% of accuracy, your machine learning technique with the relevant data should be able to provide you an accuracy beyond 80%. Then expected levels of false positives is also another important factor, because lesser the false positive is better. But you might get some sort of a false positive. So you have to come up with a threshold level. Okay, what is your expected level of false positives? And based on that, you can decide the machine learning technique for the relevant data. Then real-time detection requirements, that should also be considered. Now, if your machine learning based intrusion detection is happening real time, it takes some time to come up with the final answer, whether it's an attack or a normal event. So you need to take into account the real-time detection requirements when choosing the technique. Right. So now let's see what is the future of intrusion detection. As cyber threats continuously evolve, right, so too must our detection mechanisms. So that is very clear. Using advanced machine learning methods with different types of data is helping create smarter and more proactive intrusion detection systems. So, therefore, continuous research and development in this field is very crucial for us to stay ahead of threats. So these are the factors that we need to consider for the future of intrusion detection. Right. Now, let me come back to this Stuxnet cyber attack, which I mentioned in the beginning, right? So, Stuxnet was the first known virus specifically designed to attack critical infrastructures, which was discovered in June 2010. So this cyber attack mainly targeted nuclear power plants, electrical power grids, and oil pipelines. So Stuxnet initially spreads via Microsoft Windows and targets Siemens SCADA system equipment configured to control and monitor specific industrial processes. So what do we mean by SCADA? SCADA means supervisory control and data acquisition. It is basically a computer-based system used to monitor, control, and manage industrial processes in real time. Okay. So Stuxnet is the first weapon to be made entirely out of code. So after this event, after the Stuxnet event, there was a rapid increase in intrusion detection research. So now I would like to show you a small video clip about this Stuxnet cyber attack.
In June last year, a computer virus called Stuxnet was discovered lurking in the databanks of power plants, traffic control systems, and factories around the world. 20 times more complex than any previous virus code, it had an array of capabilities. Among them, the ability to turn up the pressure inside nuclear reactors or switch off oil pipelines, and Stuxnet could tell the system operators everything was normal. Unlike most viruses, Stuxnet doesn't carry the usual forged security clearance that helps viruses burrow into systems. It actually had a real clearance, stolen from one of the most reputable computer technology companies in the world. It exploited security gaps that system creators are unaware of. These holes are known as 0 days, and the most successful viruses exploit them. The details of a 0 day can be sold on the black market for $100,000. Stuxnet took advantage of 20 0 days. But once it got into a system, it didn't always activate. Buried deep in the Stuxnet code was a specific target. Without that target, the virus remained dormant. What was it looking to shut down? The centrifuges that spin nuclear material at Iran's enrichment facilities. Stuxnet was a weapon. the first to be made entirely out of code. The Washington-based Institute for Science and International Security says the virus may have shut down 1,000 centrifuges at Natanz, Iran's main enrichment facility, last year. In November, the International Atomic Energy Agency, the UN's nuclear watchdog, said Iran had suspended work at its nuclear facilities without explaining why. Many observers credited Stuxnet. Last month, the Iranian government conceded the virus's infection of the Bashir nuclear facility, still under construction, meant that switching the plant on could lead to a national electricity blackout. Iran has responded to the attack with an open call for hackers to join the Iranian Revolutionary Guard and has reportedly amassed the second largest online army in the world. So who was behind Stuxnet? There's no evidence beyond rumor. Some have it that Israel is responsible because the virus code apparently contains references to the Hebrew Bible. Others believe the US was involved in the testing and development. The finger has even been pointed at Siemens mobile phone company, whose software is used by the Iranian regime. The most important question may not be who designed it, but who will redesign it. The evolution has been so fast that 9 months after its detection, the first virus that could crash power grids or destroy oil pipelines is available online for anyone to download and tinker with. You can watch people on YouTube pulling Stuxnet apart. It's an open source weapon. And there's no way of knowing who will use it or what they will use it for.
Okay. So with that video, I believe you have understood how dangerous this kind of, organized criminal activities could do to critical infrastructure. Okay, so finally, I would like to present a book that I have written together with Dr. Chaminda Hewake as well as Professor Dushmant Nalin Jayakodi. This is about data protection. That means how we protect data from intrusions using machine learning and artificial intelligence. So you can have a look at it if you are interested. Right, so thank you for your attention.
For that insightful presentation and for sharing your expertise with us. We truly appreciate the depth you brought to today's session. Also, we have a special guest segment lined up for you today. Joining us is one of our own students who will be sharing his experience with SLTC and giving us an update on where his journey has taken him. It's now my pleasure to welcome Mr. Kais Nurhamid, alumni from Faculty of Engineering, to the session. Over to you, Kais.
Good evening, everybody. So thank you very much for having me here so that I could enlighten you all on my experience with SLTC Research University. So I joined in 2020 and I joined the 7th batch of Electronics and Power Systems Engineering. So the experience has been actually, it's very unveiling. That means what I wanted to do and what I'm doing now, there's a significant difference in how I have performed. Not just me, but most of the students in the campus. So if I want to explain simply, SLTC is actually a place of opportunity. It's a place where like everybody gets a chance to shine. So obviously there are several clubs, there are societies, there are competitions, and there are lots of extracurricular activities everybody can join. But in my journey throughout campus, from 2020, we had the COVID-19 pandemic, and then we had the economic crisis. So few of our time was actually online. Then when I joined back, so I met a couple of my friends from the same batch, Manusha, Sithira, Teshan. So we actually thought, COVID-19 came, then there was an economic crisis. So we actually thought of finding a solution for this, not the economic crisis as a whole, but for the fuel crisis that was going on during that period. There was a huge shortage of diesel. So diesel is like 70% of the transport sector in Sri Lanka. So we wanted to, find a way to help the country. So that's where really our real university experience started, finding a solution for a current problem. And the university actually helped us significantly throughout this journey. And even the job we're doing right now is related to a project we started 3 years back in the campus. So yeah, let me just share my screen so that I could give you all an idea on what went down the past 3 years. Yeah, so as I mentioned, couple of friends, we started with, assignments and all that. And so we got together, and in 2022, we were doing some experiments on how we can make coconut oil. So this is nothing regarding university stuff, right? So this was our own idea. So Manusha, he had this idea that he wanted to produce coconut oil. Then, we also got involved. So we were really interested. And then came the economic crisis, and we couldn't continue much of the work. So the coconut oil that we actually produced, it became spoiled, and we were looking to recover this spoiled sample. And that's when we knew that this coconut oil, you can convert this one into biodiesel. And so we got the approval from the chemistry lab that is in SLTC. Now, actually, we are electronic and electrical engineering students, right? So we wanted to, try some chemistry, and the university allowed us to conduct our experiments, and they had lab assistants to help us. And then fast forward to 2023, the biodiesel that we created in the lab, we got it tested at CPSTL, that is basically, CPETCO, Ceylon Petroleum Corporation, and then Slintech and ITI labs. These are massive recognized labs in Sri Lanka. And we took our small sample and we scaled it up. That means, so one of our friends' father, he had a yard, and we started doing this experiment in a much larger scale. That means about 50 liters we were producing. And then you can see, I hope my screen is visible. You can see that there's Sri Lanka's first ever biodiesel powered shuttle service. So we were making biodiesel, and we were supplying this to a bus that was provided from the university. And this acted as a shuttle service during the time where transport was very scarce. And then fast forward to last year, 2024, that's when we started actually approaching several companies on how we can scale this up much larger, to a much, maybe run several buses or whatever vehicles that run on diesel. And Advantis Bunkering, which is actually a company under the Haley's Group, it's a very big logistic company. So we collaborated with them, and we designed a machine that is a pilot plant which can produce 100 liters of biodiesel a week. So they had several vehicles from their operations which we used to do our experiments and supply biodiesel. So you can see here, this is our machine that we had designed and implemented, and we have conducted several tests from this from the product we have received from here, and then we have supplied this to a cement carrier. Then there's a prime mover, that is basically these large trucks that are able to transport containers, and then they have their engines. They have separate bench engines which they fix to cement carriers. So we have done several experiments on these vehicles, even a boat that is at the port of Colombo. So all these vehicles, they are currently running on the biodiesel that we have produced using our machine. So where we are now is, we are not looking at a set of vehicles. Now we are looking at supplying biodiesel to vessels. So we are working with advanced bunkering, and we are trying to, we are doing a feasibility, and we are trying to design and build a large scale factory that, can produce several thousands of tons of biodiesel to support several vehicles. So that is where we are standing right now. And this would not be possible if it wasn't for the support of SLTC Research University. So it comes back to my point that SLTC is somewhere they like to recognize and showcase the students' talents and whatever their innovative ideas are. So, if you all are joining the campus, my best advice is, whatever the ideas you all have, present it to your lecturers, to the staff members. You are definitely going to get support on whatever you're planning to pursue. So thank you very much.
Thank you very much for walking us through your journey and sharing your valuable experience, adding a great value to today's session 5. And now we'll open the floor for questions. Like if you have anything you would like to ask, this is the ideal moment. So please feel free to use the chat box for the questions. All right, looks like we don't have any questions. So before we conclude, I would like to highlight a few points about SLTC, which is a 35-acre fully residential campus with a safe in-campus accommodation covering canteens, medical center, gym facilities, and well-equipped libraries, providing a complete and supportive environment for academic and personal development. Moreover, if you would like to connect with us for more details, please feel free to reach out through our hotline, which is 011-799-000, or you can visit our website, www.sltc.ac.lk, which is also displayed on the screen as you see here. And thank you very much again to everyone who joined us today, even in this situation. So stay safe and have a wonderful evening. Thank you very much.
Thank you.